Welcome to NAROJ Masters Academy. Today we are going to discuss about the lecture number 2, okay, of electricity. So in this session, today we'll discuss what is current and what are the problems based on the concept of Ohm's law and the current and all. Okay. So before going to discuss about the Ohm's law and all, we'll discuss about the physical quantities. So what are the physical quantities? Basically, anything that can be measured is a physical quantity, like speed, okay, which can be measured, and velocity can also be measured, current also can be measured, is it right? So here we can see that the running race in terms of meters, is it right? So distance is a physical quantity which can be measured, and the time is also a physical quantity which can be measured, is it right? And the same time, if at the same time, if you see that the happiness and the love or sadness, is it possible to measure? No. So that's why it is not a physical quantity. So love is not a physical quantity. Okay. So basically, we are having some units to understand in this concept in this chapter. Units are of system of measurements. Okay, we're having basically MKS system and as well as the CGS system. MKS stands for meter, kilogram, and second, whereas CGS stands for centimeter, gram, second system. So here MKS is also known as simply what we can say SI unit, system of international units. Okay, MK stands for meter, kilogram, second. CGS stands for centimeter, gram, second. Okay, is also known as SI system. System of international units or systems international units or standard international units. Okay. Now coulomb is the quantity of charge. Okay, so charge which we measured. So SI, it is the SI unit of electrical charge. Okay, what is coulomb? It is denoted by C and it is the SI unit of electrical charge. So, Sir Coulomb, electric charge is measured by Coulomb. Okay, he is the scientist who discovered this charge. So that's the name reason why we kept that Coulomb as the unit of charge. Okay, and two like points charges. You can see that both are positive and both are negative, and having the equal magnitude. Okay, but when they are placed at one system a particular distance, they will repel with each other, is it right? So placed in a vacuum, if you look at the distance of that 1 meter from each other, okay, then repel with each other. So that is some due to extraction, and what we can say due to the force which is present inside the what we can say the charge. So here the distance is now the force which is acted on these charged particles is 9 into 10 power 9 newtons. So each charge is called as 1 coulomb. So what is the charge means? The force which is acted here. So each charge we call it as 1 coulomb. So the charge of one electron is 1.6 into 10 power minus 19 coulombs. Okay. So the magnitude of charge on a particle is given by the formula Q is equal to N into E, where N is equal to Q by E here. Okay. So Q is nothing but charge is number of electrons. N is equal to for one charge. So for one electron, you can see that the charge of electron is 1.6 into 10 power minus 19. So N is equal to 0.625 into 10 power minus 10 power 19 is the right answer. Okay, 1 by 1.6 is value is 0.625. So into 10 power 19. So what is the value of n? That is a standard constant value. N is equal to 0.625 into 10 power 19 or 6.25 into 10 power 18. Both are same only. So if we want to remove the decimal point, if you want to remove this decimal point, simply shift the point here and remove 1 power of 10. Okay, 6.25 into 10 power 18 n value. So volt. This is discovered by Mr. Sir Volta. Okay, so is it is a SI unit of potential difference, also known as voltage. Okay, and this the same unit is for EMF also, electromotive force. So we can see that the danger symbol in our daily life anywhere like the transformers and any other uh, big circuits. Okay, substations and all. So they keep the small like a high danger voltage or a high voltage. So it means we are not supposed to touch or to, not supposed to go nearby that substation and all. So danger symbol represents what? Having a more voltage. Okay. Volt is a unit for measuring the potential difference. Okay. Volta. Scientist who discovered voltaic cell. Scientist who discovered voltaic cell. Okay. Now you can see that take as electrical circuit which is connected with a battery having plus and minus terminals, positive and negative terminals, and you can see that potential difference, the difference between the positive terminal and as well as negative terminal. So higher potential to the lower potential. The difference is nothing but potential difference. Is that right? When the charge is flowing from positive terminal to negative terminal, you can see that Q is flowing through the conductor. Okay, in a given time t. So this is the direction of charge and work has been done here. Work done in moving the charge. So voltage, potential difference can be measured in terms of work done per charge. Work done per charge. So V is equal to W upon Q. Is it right? So it is also very important formula. Okay. So joule per coulomb. Work can be measured in terms of joules, joule per second. Okay, work done and per coulomb. Coulomb is the unit of charge. Volt is equal to here joule per coulomb. Okay, work can be measured in terms of joules and charge is measured in terms of coulombs. So volt is equal to joule per coulomb is the right answer. So 1 volt is equal to 1 joule per 1 coulomb. So 1 volt is the potential difference between the 2 points in a current carrying conductor when 1 joule of work is done to move a charge of 1 coulomb from one point to another. Okay, 1 volt is equal to 1 joule per coulomb. So 1 millivolt is equal to 1 by 1000 volts. That equal to 1 by 10 power 3 volts. 1000 is also equal to 10 power 3. Is it right? So that equal to 10 power minus 3 volts. 1 millivolt is nothing but. Whereas 1 kilovolt means kilo means 1000. So 10 power 3 volts. Whereas 1 megavolt means 10 power 6 volts. Is it right? Ampere. Ampere is nothing but what? It is the SI unit of current, electric current. Okay. So ampere is a measure of current. It is a unit of current. Simply, current is nothing but what, which we have discussed in the previous session, flow of charge in a given time. Is it right? So here I is the symbol which is used to represent current. So 1 ampere is equal to 1 coulomb, that is charge per 1 second. Is it right? 1 ampere is equal to 1 coulomb per 1 second. So this is also very important to know. So you can see that 1 ampere which is measured on the which is mentioned on the battery like cell. Ampere is the unit for measuring the electric current. Okay. Sir Andrew Mary Ampere. Okay. Look at the same circuit having the higher potential and lower potential, and when the charge flows through the conductor, that is Q in a given time T. Okay. Charge per time is nothing but current. I is equal to Q by T. Is it right? So electric current is equal to electric charge by time. So ampere is equal to coulomb per second. Okay. So 1 ampere is equal to 1 coulomb per second. 1 ampere is constituted by the flow of 1 coulomb of charge in 1 second. 1 milliampere is equal to 1 by 1000 amperes. That equal to 1 by 10 power 3 amperes. 10 power minus 3 amps. So match the following. So far whatever we have discussed, we have to check with these answers. On the left hand side, we are having electric current, electric charge, and potential difference. Right hand side, current is nothing but measured in terms of amperes. So electric current is option B, ampere A, and electric charge, coulombs, sir coulombs. So option C for the second one. Potential difference, sir volta. Okay, volta is the right answer, option D. And joule is for work. Joule is for work. Okay, now we'll discuss a few numericals based on this concept. The type A type questions based on Q is equal to IT, or W is equal to VQ, or V is equal to W by Q, or I is equal to Q by T, and then Q is equal to NE formula. Okay. Now look at the question number one. A current of 0.5 amperes is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric charge that flowing through the circuit. Directly given in the question, current is how much? 0.5 amperes. I value is given. Drawn a filament by of electric bulb for 10 minutes. Time is given. T is equal to also given 10 minutes. So we should not write in terms of minutes. We have to write in terms of seconds. So 10 into 60, that equal to 600 seconds. Is it right? Find the amount of electric charge that flows through the circuit. Electric charge Q is equal to question mark. Is it right? So we know that Q is equal to I into T. Okay, I is 0.5 into 600, that equal to 1 by 2 into 600, that equal to 300 coulombs. Is it right? Very important and very easy question. So the charge flowing through the circuit is 300 coulombs. Okay. How much work is done in moving of a charge of magnitude 2 coulombs from a point 118 volts to the point 128 volts? So here we have to check with the difference of the potential. Okay. Potential differences we have to check. 118 volts and 128 volts. So what is the difference here? 10 volts is the difference. So the potential difference is how much? V is equal to 10V, and the Q is how much? Q is equal to 2C. Okay, and what he asked, how much work? W is equal to question mark. Is it right? W is equal to question mark. So we know that V is equal to W by Q, then W is equal to V into Q. So that equal to 10 into 2. So that equal to 20 joules. 20 joules is the right answer. Is it right? So very easy question. So he asked that how much work is done in moving a charge of magnitude 2 coulombs from 118 to 128 means 20 joules. Is it right? So the work done is 20 joules. Calculate the number of electrons constituting 1 coulomb of charge, or show that 1 ampere is equal to the flow of 6.25 into 10 power 18 elementary charge. So we know that very well. The charge of an electron is E is equal to 1.6 into 10 power minus 19 coulombs, and Q is equal to what? That is charge is equal to 1 coulomb. So number of electrons is equal to N. Then formula to find that is Q is equal to Ne. So substitute here. Q is equal to N into E. In that, N is equal to Q by E. Q is 1 coulomb and E is 1.6 into 10 power minus 19 coulombs. That equal to 6.25 into 10 power 18 number of electrons. Okay. So the number of electrons constituting 1 coulomb of charge is equal to 6.25 into 10 power 18. Is it clear? Next question. How much work is done in moving a charge of magnitude of 2 coulombs across 2 points having the potential difference of 12 volts? So here clearly given 12 volts is the potential difference. How much work is done? W is equal to question mark. Is it right? And for charge is Q is how much? 2. So answer is 2 into 12, 24. Is it right? So work done is equal to P into Q, that equal to 12 into 2, that equal to 24 joules. The work done is 24 joules. How much energy is given to each coulomb of charge passing through 6 volts battery? Energy given to each coulomb of charge. So here charge is equal to 1 coulomb, potential difference is 6 volts. Energy given by battery is W. Okay. So here W is equal to V into Q, 6 into 1, so 6 joules. Okay. 6 joules is the right answer. So energy given by battery is 6 joules. How many electrons are flowing per second past a point in a circuit in which there is a current of 5 amps? Current is equal to 5 amperes, time is equal to 1 second. Then charge is equal to 1.6 into 10 power minus 19 coulombs. Then to find the number of electrons, n is equal to q is equal to it, we know that, and q is also equal to na. Then we have to equate these two. Okay, simply equate it is equal to ne, and then n is equal to I into t by e. I is how much? I is 5 into t is 1 by e is 1.6 into 10 power minus 19. So here 1 by 6, 1 by 1.6 into 10 power minus 19 is also equal to 6.25 into 10 power 18 into 5. So it will be 5 6 are 30 and 5.2 30.25 something. So 31.25 into 10 power 18 is the right answer. So we will get the value of 31 point something into 10 power 18 is the right answer. Okay. From equation 1 and 2, we have to get this value 31.25 into 10 power 18 electrons flowing per second. Is it clear? Now look at the next question. An electric heater is connected to a to 230 volts main supply. A current of 8 amperes flow through the heater. How much charge flows around the circuit in each second? Charge flow of charge in each second, he asked. So charge is nothing but Q. Is it right? Q is equal to what? Here V is given. Current is also given. So V is equal to 230 volts, and I is equal to 8 amps. So we don't have the direct relation to find the charge. Is it right? How much energy is transformed to the heater in the each second? Energy transformed, so that is W is equal to how much in each second. Is it right? So W is equal to, what is the formula? Q by V. V is equal to W by V is equal to W upon Q. Is it right? Then W is equal to what? V into Q. So we should get a Q value. So what is the formula to get Q? Q is equal to NE. Is it right? So that is one option. Q is equal to I into T. Is it right? So here time is given per second, for each second. Time is each second. Yes, each second means 1. So I is how much? 8 into 1, that equal to 8. So Q is 8 only, and then V is equal to how much? V is equal to how much energy? W is equal to how much? W is equal to Q is 8 coulombs into V is 230. 8 into 230, 1600 plus 24, 240, 1840 joules. Is it right? So very easy to answer. So this is for first bit, A bit, and this is for B bit. Is it right? So shall I explain once again? Okay. How much charge Q is flowing? How much charge is flowing around the circuit in each second? Each second means time is equal to 1 second. Is it right? So connected to a voltage, V is equal to how much? 230 volts. And a current of I is how much? 8 amps. So we know that first question, how much charge is flowing? As per first bit, A, Q is equal to question mark. Q is equal to I into T, that equal to 8 into 1, that equal to 8 coulombs. Is it right? Now second bit, how much energy is transformed? Energy is nothing but in terms of joules. W, okay, is equal to question mark. We know that V is equal to W by Q. Then W is equal to V into Q. That equal to V is how much? 230 into Q is how much? 8. That equal to 1840 joules. Is it right? The potential difference. Each and everything is given here, so we can find the values of both easily. Thank you. So we'll discuss in the next session.